Good evening, everyone, and thank you for your patience on our late start. If you are new to the session, to the Math Monday sessions, welcome. If it's not your first time, welcome back. So this is the third and final session for the Mathematics Monday Live. So we're going to jump straight into today's objectives. Also, let me apologize for any of my background noises that you may hear or may be hearing currently. So of course, at the end of the session, the live will be recorded, of course, and posted at the end, as were the past sessions or videos. Right, so today we're going to look at integers at large. So we're going to do addition and subtraction of integers. And then we're going to look at multiplication and division. And then secondly, we're going to tackle transposing or rearranging of formulae, also or sometimes called transposition. Right, so let's talk again about what is integers. So in our first session, we looked at integers or integer numbers in classification or under classification of numbers. So an integer or integers are numbers that include that include positive numbers, negative numbers, and zero. Integers have no decimal or fractional part. And there's a little image there of a timeline that shows you what integers include. So if you go back to our video on classification of numbers, you would know that integers, as definition says, includes positive numbers, negative numbers, and zero. So natural numbers and whole number classifications are part of the integer system or the integer category. So let's look at addition and subtraction of integers. So of course we have rules to follow when adding and subtracting integers. So if we have the same sign, if we're adding and subtracting the same sign, we're going to add the numbers and keep the sign. And if it's different signs, we're going to subtract the numbers and keep the sign of the larger or the absolute number or the absolute value. Right, so we're going to delve straight into some examples. So on the screen, we have 2 add 2 or 2 plus 2. So if we consider what we looked at before about things you should know about a number, we know that if you have nothing in front, no sign in front of a number, it is understood that there's a positive value. So that first 2 there is a positive 2 because we weren't given any sign. It's positive 2. Now the second 2, there's a positive or there's an addition operation there. But if we were to separate this and understand what that operation means, when we have an addition sign in between 2 integer numbers, we can see that this addition sign can be split into 2 negative signs or 2 positive signs. So remember, if we go back to the rules of adding and subtracting in integers, they said same sign, we add and keep the sign. So I can say that that addition there is either 2 negative signs or 2 positive signs. So when we have 2 negative signs or 2 positive signs, we just replace it with an addition sign. So if I were to ask you, what does that mean? Just think in your head, an addition that comes in between 2 integers can be replaced with 2 negative or 2 positive signs. So if we were to calculate this equation or this sum, we know that 2 plus 2 will be equal to 4. So we add, same sign, we add and keep the sign. So there's positive in front of 2 of them. So we add and we keep the sign. So this is actually positive 4. So we know that when we have a positive number, we don't have to write that plus sign because it's understood that any number without a sign is positive. So we can either put positive 4 or we could just put 4. What if we had -2 take away 2? So that first 2 has a negative sign in front of it, so that's obvious, it's negative. But there's a negative sign in front of the second 2. So that negative sign, it dictates whether the second number is positive or negative. So of course it's going to be negative. And it also tells us the operation of the sum. So if I were to split, just like I split the positive sign in the first problem, I can split it in the second one as well. So I can say this is the same as saying -2 take away +2. Or I can say it's the same as -2 add -2. So once we have different signs coming together, we can rewrite it as subtract. And remember what they told us. The rule is same sign, we add the numbers and keep the sign. So if I add 2 and 2, if I add 2 and 2 together, I'm going to get 4 again. But the same sign that we have there is negative. So I'm going to end up with -4. So remember, same sign, we add the values and keep the sign. So same sign, we add the values and we keep the sign. Right? So I know I said we were going to do addition of integers only, but I kind of went astray and went quickly into subtraction. So we've added +2 and +2, and then we've subtracted -2 from -2. But what if we had -2 add 6? So remember, we said when we have different signs, so we have a negative and then we have a positive. When we have different signs, we're going to subtract and keep the sign of the larger number. So I'm going to take the larger number, which is 6. If I take away 2 from that, I'm going to get 4. And then we're going to keep the sign of the larger number. So the 6 here is the larger number, and the sign that dictates that 6 is positive. So then my answer is also going to be positive. Then if I add, let's just say, 4 add negative 13. So 4 add negative 13. So here's where it gets a little tricky. So we have 4 add negative 13. So of course we know that 4 in front there is positive because it doesn't have anything in front of it. But remember, when we have two signs coming together, we can replace it. So if I have a positive and a negative sign, that's different signs, that can be replaced with minus or subtract or negative operation. So I'm going to have positive 4, which I can just write as 4. Different signs is going to give me negative. And then I'm going to put back the 13. So remember, when we have different signs, we subtract and keep the value of the larger number. So if I have 13, take away 4, I'm going to end up with 9. And then the sign of the larger value is negative because I have a positive 4 and I have a negative 13. Negative 13. So we take away and we keep the sign of the larger number. So this is going to give me negative 9. So my answer is going to be negative 9. So I know I touched on subtraction, but we will look at some more examples. So if I have, addition and subtraction, the same rule applies. Same sign, we add and keep the sign. Different signs, we subtract and keep the sign of the larger value. So if I have 7 take away 3, we understand that this 7 is positive. And then I know I can split this negative sign into negative and positive, or positive and negative, it doesn't matter. So if I were to rewrite that, I could put positive 7, take away positive 3. If I wanted to, I could rewrite it. So positive 7, take away positive 3. So if I wanted to, I can look at it as same sign. So we just subtract in there. Or I can look at it as different signs. So you have to find the way that is easier for you. So I have positive 7, take away 3. So we know that if it's different signs, we're going to subtract and keep the sign of the larger number. So 7 take away 3 gives me 4. And of course, the sign of the larger number is positive. So this is going to be positive 4. That's how we kind of verify. So we know that 7 take away 3 is 4, yes, but is that 4 positive or negative? Of course, it's positive because the larger number, which is 7, is a positive number. So that's one way of verifying if your answer is correct. What if we had negative 10 subtract negative 1? So if we apply rules, I can just separate this using brackets. Let me use a different color. So if I want, I can say same signs. So we add and keep the sign of the larger number. Sorry, we add and keep the sign, sorry. Or I can look at it this way. I have two negative signs coming there together. So this is the same as saying add. So then if I want to rewrite this, I can say, because sometimes when we have two signs coming together, it kind of confuses us a little bit. So if we have two signs coming together, if they're the same, we're going to just replace it with an addition. And if they're different, we're going to replace it with subtraction sign. So I can say -10 add 1. I can replace those two minus signs with just an addition sign. So -10 plus 1. So what we do, we subtract and we keep the sign of the larger number. So 10 take away 1 because it's different signs. So we're going to subtract. 10 take away 1 gives us 9. And we're going to keep the sign of the larger number. So the larger number is -10. So we're going to keep the sign. So our answer is going to be -9. So of course, as I said, these sessions are recorded, so they will be left on the YouTube channel so that if you need to review, you can review. So you're going to look at a few more, and then we're going to move on to multiplication and division of integers. What if we had +7 take away +9? So anytime you have two signs coming together, always try to replace it with one sign to make it easier for you to calculate your answer or work out your answer. So remember, when we have different signs coming together, we can just replace it with a negative sign. So different signs can be replaced with a negative sign. So if I wanted to rewrite this question, I can say this is +7 take away 9. Different signs, we subtract and keep the sign of the larger number. So 9 take away 7 will give us 2. And the larger number is -9. So this is going to be -2. So our answer is -2. So +7 take away +9 gives us -2. Let's look at another. So we have -3, take away +5. So remember, the opposite signs, well, different signs can be replaced with negative or just take away or subtract. So here I'm going to have -3 take away 5. So now we've changed it. We've altered the question to make it easier for us to do. So instead of having those two signs in between there to confuse us, we've replaced it with just subtraction. So when we have, so now we have the same sign. If we look at that second step, which is this, we have the same sign coming together. So the rules of same sign when it comes to addition and subtraction of integers is that we add the two numbers and keep the sign. So 3 add 5 gives us 8. And of course, we're going to keep that negative sign. So our answer is -8. Another way we can consider doing integer addition and subtraction is by use of a number line. So I'm going to do one example using number line. So if I have 5 add -4. Now remember that equal. So that first 5 there, of course, it's a positive. That's understood because it doesn't have anything written in front of it. And these two signs here can be replaced with take away, subtract, minus, whatever you want to call it. So now if I want to rewrite this question, I can write it as 5 subtract 4. So if I were to use a number line to do this question, let's say our number line, usually 0 is in the center. And I'm just quickly sketching a number line there for you. So our first value is +5. So we have to look for +5 on our number line. So I have located +5. And then if we have our operation tells us the direction we have to move in. So here I have subtract. So subtract tells us that we have to move to our left. If we are adding, we're going to move to our right. So if we're starting at +5 and we want to subtract 4, then I have to move 4 times to my left. So that's 1, 2, 3, 4. And I'm going to stop there. So my answer is 1, +1. So that's how we use a number line to do our integer questions. So I know I said I was going to do one example, but I'm just going to do one more. And then we'll move on to multiplication and division of integers. Right, so as I said, as long as you have two, so that new question we have there, that new sum, that new problem is positive 2, take away negative 2. So remember I told you once you have two signs in the center, replace it. Do not keep the two signs. So we know once we have the same sign coming together, it's going to be replaced with positive. So if I rewrite this, this is going to be positive 2, add 2. So remember, with addition and subtraction of integers, once we have the same signs, we're going to add and keep the sign. So 2 add 2 is 4, and the sign that we have there is positive 4. But let's work that out on the number line. So let's use our number line to verify. So I'm starting off at positive 2. So that's here. And I'm adding 2. So if I'm adding, we have to move. If we're adding, we're moving to our right. So we're going to go to our right. So this is telling us, this addition sign is saying, go to your right 2 times. So you're going to go 1, 2. And our answer is positive 4. So that's one way to verify. Using a number line is one way to verify that the answer that you've worked out for your integer problem is correct. So now we're going to look at multiplication and subtraction. So of course we have rules just like addition and subtraction. The same sign, your product or your quotient. So basically this is just saying your answer. So when you multiply, your answer is called the product. When you divide, your answer is called the quotient. So basically product and quotient is just saying whatever answer you get. Once we have same sign, whether we are multiplying or dividing, your answer is going to be negative. And for different signs, sorry, that's an error. So same sign, your answer is going to be positive. And opposite sign, your answer is going to be negative. So let me correct that one time. Right, my apologies again. So the rules of multiplication and division of integers, once we have the same sign, your product or quotient is going to be positive. And once we have different signs, it's going to be negative. So we're going to look at some examples to help clarify those rules. So let's look at some multiplication. Right, so the rules, same sign, your answer, or your product. So for multiplication, your answer is referred to as your product. So for the same sign, your product is going to be positive. And for different signs, your product is going to be negative. So here we have -2 multiplied by -2. So the product of 2 and 2 is 4. And because we have the same signs, then our answer is going to be positive. So if we want, we can put that addition sign in front of that positive sign, or we could just leave it alone, because we know that if we don't write it, it will be understood that the number is positive. So let's look at the second question. So we have +7 multiplied by +10. So 7 by 10 is 70. And because we have the same sign, so we have addition here, and then we have addition of positive and positive, then our answer is going to be positive. So we could leave that as 70. If you want, you can write the addition sign in front, but we know that with positive answers, we don't have to write it. So +7 multiplied by +10 gives us +70. So the third example we have there is -3 multiplied by 4. So are we going to use the rule of same sign or different sign? Which rules are we going to use? Same sign or different signs? Right, so for this one, we're going to use different signs because we know that that 4 there is actually +4. So -3 multiplied by +4. So 3 by 4 give us 12. And remember, once we're multiplying different signs, our answer is going to be negative. So -3 multiplied by +4 gives us -12. So same sign, we get a positive product or a positive result or a positive answer. And different sign, we're going to get a negative product. So this is when we're doing multiplication of integers. And of course, the same rules apply when we're doing division. So if I have -5 divided by 1, what is my answer going to be? So remember, same sign, positive quotient, positive result or positive answer, different sign, negative answer. So we should know by now that this 1 is the same as saying +1. So now I have -5 divided by +1. So I know 5 divided by 1 will give me 5. And because these signs here are different, I'm going to end up with -5. So let's just say I had -21 divided by -3. So what we're going to have here, 21 divided by 3 will give me 7. And because we have the same sign, this is going to be +7. If we have 64 divided by 8, we should know by now that this is +64 and this is +8. So 64 divided by 8 will give us 8. And because we have the same signs, this 8, our quotient, is going to be positive. So we're going to look at one more example for division of integers. So we have 32 divided by -4. So you know that this 32 is positive because we didn't have any sign in front of it. So 32 divided by 4 gives us how much? When we divide 32 by 4, of course, good, we get 8. And because it's different signs, you're going to have -8. Another way we can rewrite when we're doing division is that we can write it as a fraction. So I could put 32 divided by 4. And I know that this 32 is positive and this 4 is negative. So once I have different signs coming here, I know that my answer is going to be negative. So 32 divided by 4 will give me 8. So you can write it as like a fraction when you're doing division. And that could actually help you compare the signs easily. So let's just say I have 12 divided by 3. I know both of them are positive integers. I know that both of them are positive integers, so if I wanted, I could rewrite it as a fraction. So we have +12 divided by +3. Same sign, our answer is gonna be positive. 12 divided by 3 is 4. Likewise, if I had negative values, so let's say I had -15 divided by -15. So I can rewrite it as a fraction. So I'll put negative 15 over negative 15. And basically when we have the same sign, it's saying like this sign is canceling out this. So only same signs can cancel out each other, more or less. So same sign, if they cancel out each other, 15 by 15 is just 1. And of course, we know once we have 1 by itself, that is the same as saying positive 1. So my answer is positive. So apologies again for my background noises. It's beyond my control. So now we're going to talk about transposing or rearranging. So let's think about the word transposing. So that, or to transpose. So that prefix trans means more or less to move or to change. So think of transport, transfer, or transform. It's some kind of movement or change that is being done if we understand what those words mean. And posing comes from the word position, or pose comes from the word position. So I am moving or changing my position. So what really is transposing in maths? So transposing refers to isolating a variable of an equation by moving its position or the position of other terms in that same equation. So we want to get a particular variable and isolate it. So we want it by itself. And the only way to get it by itself, because to isolate means to be alone, to get it by itself or to get that variable alone, we will have to either move its position or move the position of everything else around it. And some of you may say, well, I don't even know what a variable is. So when we talk about variables, we're really going into algebra. So algebra is when we introduce letters into our mathematics. So we're not just using numbers and operations, but we're now introducing letters. So I'm going to give you an example. So let's just say I have 2x equals 6. In that equation, so I know it's an equation because we have an equation sign. If you see a particular problem and there's no equation sign, it's not an it cannot be called an equation, it's an expression. As long as you have a problem, a sum, whatever it is, and there's an equation sign in there, it's an equation. No equation sign is called an expression. Right? So in front of us, the equation we have is 2x is equal to 6. In that question, x is our variable. So in most instances, your variable is going to be a letter or a symbol. So for some of the SEA students, a symbol, a common symbol that we use at primary school level is pi. That's a symbol, right? Sometimes we use theta and so on. But x is a letter of the alphabet. So in this particular question, x is our variable. So a variable, think of the word to vary. A variable is something that can change. So we are saying that x could change. So because it could change, the value of x can change. X is our variable. So the variable doesn't have to be x. As I said, it could be any other letter of the alphabet. It could be a symbol. But the variable just tells us this is the item or the term that can be changed. When we have letters by itself, letters by themselves are called constants. sorry, not letters, numbers by themselves are called constants. So letters, variables, numbers by themselves are called constants. So there's 2 in front here. When we have a number in front of a variable, that number is called a coefficient. So a coefficient is a number that tells us that we have to multiply that variable, whatever value we get, that number of times. So when you have a number and a variable coming together, it's basically saying that we are multiplying in between here. We have to multiply that variable by that number, and that number is called a coefficient. So the coefficient of x is called, or in this particular equation, is 2. The coefficient of x is 2. So what we say, we wouldn't say 2 multiplied by x, but we'll just say 2x. So 2x, once you hear that term, understand that multiplication is taking place. So that 2 there is the coefficient, the x is the variable, and the 6 by itself is called a constant. So once you have a number by itself, it is called a constant. And of course, those 2 dashes there, that's our equation sign. So we know that. Don't forget. So our letters or symbols in an equation is called a variable. And once there's a number directly in front of a variable, that is called a coefficient. This is telling us that we have to multiply that variable this amount of times. And numbers by themselves, sorry, are called constants. Right? So remember that a variable is just something that can change. So when we talk about transposing, we're just saying that we have some equation and we want to isolate some variable in that equation. So we're going to look at examples. So of course, when we transpose, there are steps involved in transposing. So the first thing we have to do is identify the variable you need. So identify that variable that you want to make the subject of your equation or the subject of your formula. So sometimes they might give you a formula to transpose, because remember, a formula is an equation. Or they might just give you a regular equation. The second thing you have to do is isolate that variable by placing it on one side of the equation sign and putting everything else on the opposite side. So you identify your variable, and then the next thing you want to do is isolate your variable. And remember, this is a key point in how we transpose. Once you move an item across the equation sign, you must perform the inverse or do the opposite operation. So you do the opposite, right? And we will look at some examples to explain that. So I'm just going to post a couple examples. And as the instruction says, we're going to rearrange to make the variable in brackets the subject. So remember, I said you can rearrange any type of equation, whether it's a regular equation of formula, anything, any type of equation you can rearrange. So let's look at a simple equation. So I'm going to take the formula for area of a triangle. So let's look at area of a triangle. So we know that area of a triangle is equal to a half base by height. Or sometimes you may see area is equal to base multiplied by height over 2. So we'll use that one. Use that one instead. So base by height over 2. So we want to rearrange to make height the subject of the formula. So this is just telling us if we were to find height of, now remember you can only have one unknown. So if we were to find height of a triangle, we could rearrange the formula for area to determine the height. So as the instruction says, rearrange to make the variable in the brackets the subject. And remember that I told you before, a variable is something that can change. So base and height can change based on the size of the triangle. So those two things are called variables. The base and the height is a variable. Those are variables of a triangle. And as long as those two things change, your area is going to change. So area of a triangle is base by height over 2. If I want to make h the subject, the first thing I have to do is identify where h is. So we see that h is right there. The next thing I want to do is isolate h. And remember, in order to isolate h, I have to keep h on one side of the equation sign, and everything else has to go on the other side. So all I am going to do is just move. If we have found h there, then I can simply just move everything else. So I'm going to move all of that and put it on the other side where area is, because we want to make h the subject. Therefore, we want h by itself. That's all it's saying. To make h the subject is just saying that we want h by itself. We want it alone. We want it isolated. That's why we are transposing, because we want it isolated. Right? So because both b and h are kind of divided by 2, I'm going to move that divided by 2 first, because that divided by 2 is really dictating both the b and the h. So we're going to move that first. We want to get rid of that divide by 2. So what I can do, I'm going to transpose this divide by 2. So now we're going to move it. So transpose means to move your position. So if I have divide by 2 and I'm moving it across the equation sign, then I have to do the opposite. So now, of course, you know, divide, the opposite of divide is multiply. So now I have a multiplied by 2 is equal to, so now I've gotten rid of that divide by 2, so I don't have it anymore because I moved it across the equation sign, is equal to b multiplied by h. But we're not done, because that's not what they asked us to find. They asked us to find h. So now, because I want to isolate h, I now have to move this multiplied by b. So I have h multiplied by b, or b multiplied by h is the same thing. I want to move that multiplied by b. So of course, you're going to do the opposite. So the opposite of multiply is to divide. So I'm now going to have a multiplied by 2. So if I'm moving this multiply across, I'm going to divide. So that means everything that is on my left is going to be now divided by b. So a multiplied by 2, all of that is going to be divided by b. And of course, that is equal to h. So I just have h by itself now. So if I want to rewrite this to make it look neat, we can just more or less flip it and just put h is equal to a multiplied by 2 divided by b. So if you stop at this point, you'll still be correct. But we'll be just naturally like to write our subject on the left-hand side. But if we stop at that second to last point, it will still be correct. So let's look at another example. So this example says y squared is equal to x. So a lot of you may look at that question and say, well, if we want to rearrange to find y, this doesn't make sense because y is already by itself. But if we look at that y, we'll see that the y is raised to a power higher than 1. So that y is squared. So that is not y. Y by itself is like saying y to the power of 1, which is the same as y. And that is what we want. We don't want y squared. We actually just want y by itself. So remember, to transpose, we locate our variable. So the variable we want is y. And then we isolate that variable by moving everything else. Either we move the variable or we move everything else to the opposite side of the equation sign. So what we actually want to do is move this square or power of 2. So we want to move that across the equation sign. Now remember, when we move things across the equation sign, we do the opposite. So if I have squared, the opposite of squared would be square root. So my next step is going to be y is equal to, and the square root, that square root or that square that we're carrying over, which will become square root, is going to govern everything on the right-hand side. So now we're going to have y is equal to the square root of x. And that is the end of what we want to find. Because remember, we want to make y the subject. So as long as we have our variable isolated, we have it by itself, that is the end. We don't have to do anything further. Once we have our variable by itself, we don't have to do anything else. So y, our new equation, is y is equal to the square root of x. All right, so we're going to look at one more example, and then we'll be done for the evening. And remember, of course, this session is being recorded, so it will stay up on the YouTube channel. And of course, if you need to review anything, if something or some part of this session was not clear to you, you can go back. Feel free to comment. If you need me to go further in depth into a particular aspect of the session, you can make that request. And I'll try my best to see how I can accommodate those requests or those suggestions. So this question tells us that we want to make, so remember they said rearrange to make the variable in brackets the subject. So there we have A. So A is in brackets, so we want to make A the subject of the formula. So what's the first step we have to do? So we have to identify where A is. So if we look to the left-hand side of the equation sign, we'll see that A is under that square root sign. So that's A. So we have identified A. So we now want to isolate A. So we have identified it. Now we want to isolate it. The only way to isolate A is to either move A or move everything else. So if we look at where that A is, it's very difficult to just move A. So it's easier to move all of the other things around because you have to move those things in order to get to A. So the first thing we're going to do is we have divided by 2. So we're going to move that across. If it's divided by 2 on the left-hand side, and we're moving it across the equation sign, it's now going to become multiplied by 2. So now I would have the square root of A. The square root of A is equal to C multiplied by 2. So remember I told you when you have a variable and a constant that is being multiplied, you can just write it together. So if we want, we can keep the 2 multiplied by 2 multiplied by C, or we can just write 2C. It means the same thing. 2C is the same as 2 multiplied by C, or C multiplied by 2. So if we want, we can keep that. Let me just write it in a different color so that you don't get confused. So now if I'm transposing this divide by 2, it's going to come across here as multiplied by 2. So I'm going to end up with the square root of A is equal to 2 multiplied by C, or C multiplied by 2, which is the same as 2C. But we're not done yet because we haven't isolated that A. We have the square root of A is equal to 2C. That's not what they asked us to find. They asked us to find A. We don't want the square root of A. So the next thing I have to do is transpose this square root. So of course, we know that when we're transposing, we do the opposite. So when we're transposing, we do the opposite. So this is going to become A. If I'm transposing, that square root is going to become square. So everything else, everything that is on the right-hand side is going to be square. So A is equal to 2C, or C multiplied by 2. All of that is squared. Or if we left the 2C as 2 multiplied by C, it would have been A is equal to 2 multiplied by C. And all of that would be squared. So whether you have 2C or 2 multiplied by C, we still want to put that in brackets because we want to show that everything on the right-hand side is going to now be squared. So that square root that we transposed to become square is governing everything on the right-hand side. So now we have A is equal to 2C squared, or 2 multiplied by C squared. So that brings us to the end of the question, because remember they told us that they wanted us to make A the subject. So because A is now the subject, we don't have to go any further. So when you're transposing or you're rearranging your formula, once you have isolated that variable, meaning that you have that whatever variable they ask you to find, it could be A, P, Q, R, S, whatever. Once you have that by itself, you have it isolated, and everything else is on the other side of the equation sign, then you have completed the question. Just ensure that when you are moving your terms, that you do the opposite. So if I have positive and I'm moving it across, it is going to become negative. If I have division, it's going to become multiplication. If I have square, it's going to become square root. So remember that you're just going to do the opposite. So I know I said that was the last question, but I just really want to do one more. I'm going to try to find a simple one, and that will be end. Right, so now we have P divided by 2. So P divided by 2, so it's common P. P divided by 2 plus 3 is equal to X. And we want to make P the subject of the formula. So if we look at the equation now, we will see that X is the subject of the formula. We don't want X as this, we no longer wish to have X as the subject. Because if you look at it, X is on one side by itself and everything else is on the other side. X is currently the subject of the formula, but we don't want X, we want P as the subject. So what will your answer be? So I'm not going to work it out. What I'm going to do is just tell you the answer. So on your own, you can work it to see if you get what I have. So your answer is going to be P. So if we make P the subject, P is equal to X. Take away 3. All of that is multiplied by 2. So all of that is multiplied by 2. And that's the answer. So if I wanted, I could rewrite this as 2 into X minus 3. It's the same as what we have on top. So X take away 3, all of that multiplied by 2 is the same as saying 2 into X minus 3, because I'm now saying that I have to multiply by 2 by everything that is in brackets. So both ways are correct. And that is the answer that you should have when you make P the subject of the formula. So you do it on your own and see if you can work to get the answer that we have on the screen. So that brings us to the end of today's session. Thank you for joining me. If you were here for all 3 sessions, thank you for being part of the process, for lack of a better word here. Feel free to like, subscribe, comment, and of course, share the videos, share our channel with anyone who can benefit from these videos. Thank you. Have a good evening.